Hello, I'm Jajitha Kakarla, currently studying fourth year pursuing M.Tech Integrated Software Engineering in Vellore Institute of Technology, India.
Hi everyone, I'm Dhivyadharshini. I'm currently pursuing fourth year in Integrated M.Tech Software Engineering in GIET Vellore, India.
So our paper number is paper 64 and the topic is an investigation on breast cancer detection techniques. Now I'll share the presentation. Breast cancer. Breast cancer is the most commonly occurring cancer in women. It is the second only to lung cancer as a cause of the cancer mortality, and it is the leading cause of death for women between the ages of 40 and 55. For every 2 minutes, a woman is diagnosed with this cancer in India, and every 9 minutes, a woman eventually passes away from the breast cancer in India. Early detection of breast cancer can improve survival rates to an extent. The medical care of the patient with the breast cancer is costly, and given the cost and the value of preservation of the health of the citizen, the prevention of the breast cancer has become a priority in public health. Over the past 20 years, several techniques have been proposed for this purpose, such as mammography, which is frequently used for breast cancer diagnosis. In this paper, the extensive study of the current techniques for detecting the breast cancer is discussed. We have also covered the issues and challenges of the existing system. According to World Health Organization, in 2020, there were 2.3 million women diagnosed with breast cancer and 685,000 women globally. As of end of 2020, there were 7.8 million women alive who were diagnosed with breast cancer in the past 5 years, making it the most prevalent cancer. Breast cancer occurs in every country of the world in women at any age after the puberty, but with increasing rates in later life. So we can reduce this number using early detection techniques, awareness and campaigns, and better diagnostics, and well as by improved treatment options. In image classification, deep learning techniques attained higher results in image classification and the detection. The detection of breast cancer at its early stages play a vital role to save most women. To achieve this, the detection system should be efficient, and it involves the following stages, which is the input stage, pre-processing, image segmentation, feature extraction, feature selection, and detection. In this paper, we will explore all the detection techniques and also see all of the stages which is involved in detecting the breast cancer. Here, there are several techniques in detecting the breast cancer. Several AI techniques are there in which machine learning, deep learning, transfer learning, and in machine learning, we have supervised and unsupervised. In that, several techniques like back propagation, linear regression, decision tree, naive bias, and in unsupervised, we have a k-means clustering, infrared thermology, etc. And deep learning, we have CNN, which is convolutional neural network, multi-layer perceptron, etc. are there. And in transfer learning, we have quantum transfer learning and also thermography neural network, etc. Coming to the first stage, which is pre-processing. So as we know, pre-processing is a process of sharpening and removing noise from data. So in pre-processing, we actually perform techniques like noise reduction, outlier analysis, and missing or mistaken value treatment. Till now, there are several techniques which are used for pre-processing in the papers which we have investigated, in which they involve scaling, compression, converting data set into frequency tables, data augmentation, stain normalization techniques. All these techniques were used. And among the pre-processing techniques which are used till now, stain normalization technique and data augmentation worked well in the pre-processing stage, which is giving the higher accuracy for the further detection of the breast cancer images.
Next, we'll move on to the feature extraction and feature selection. Feature extraction module is used to extract features in a format supported by machine learning algorithms from the given data sets and consisting of formats such as text and image. The feature selection module is used for feature selection or dimensionality detection on given datasets. This is done either to improve estimators' accuracy scores or to boost their performance on very high dimensional datasets. So the main difference between them is feature extraction transforms an arbitrary data such as text or images into numerical features that is understood by the machine learning algorithms. So the feature selection, on the other hand, is a machine learning technique applied on these numerical features. Okay, so now we'll see briefly about the feature extraction techniques. The previous slide, please. Yeah. So here we identified several techniques like discrete wavelet transformation, principal component analysis, LDA, multidimensional scaling, ROI with adaptive mass region detection, multidimensional feature extraction using convolutional neural networks, deep belief networks, sparse autoencoder, fractional Fourier transform, inception exception models, principal component analysis combined with multi-layered perceptron, hybrid classical quantum model. Okay, so among the feature extraction techniques which are used, the DWT worked well in which, including this feature extraction technique, the model provided an accuracy of about 93%. So next we'll move on to the feature selection techniques. So here we identified several techniques like genetic algorithm, correlation, Bayes theorem, Pearson correlation matrix, F1 distance, and etc. So here, using the genetic algorithm, they achieve the highest accuracy. The authors have suggested a two-stage system. So to lower the computational complexity, unnecessary features are first discarded using a genetic algorithm. Then by utilizing the Wisconsin Diagnostic Breast Cancer databases, these technologies have been used, and 14 genetic algorithm-based features achieved the highest accuracy of 99.48%. So next we'll see about the data sets. These are the various data sets used for identifying breast cancer. This includes both image and numerical data sets. So that's variable data set. So next we'll see the classification as per the flowchart. Yeah, so we divided all the techniques into machine learning, deep learning, transfer learning. So under machine learning, we divided into two subdivisions. They are supervised and unsupervised. So first we'll see about the supervised. They use the label data sets to train algorithms to classify data or predict outcomes accurately. So in supervised, we identified techniques listed in the table. So among them, AdaBoost classifier achieved the highest accuracy of 97%. In AdaBoost classifier, it is like a meta estimator that begins by fitting classifier on the original data set, and then it fits the additional copies of the classifier on the same data set, but where the weights of incorrectly classified instances are adjusted such that the subsequent classifiers focus more on the difficult cases. So like it can be used for like malignant cases, most probably. Yeah, that's it. So the next part will be continued by Jajitha.
Here we have unsupervised techniques. So unsupervised learning is a type of algorithm that learns patterns from the untagged data, which is unlabeled data. So here we have several algorithms. It is infrared thermography, artificial intelligence with the radiomics, and k-means clustering Gaussian mixture. In these algorithms, the k-means clustering algorithm showed the highest accuracy, which is of 98%. K-means is a simple approach for categorizing a dataset using k clusters. It looked into how integrative clustering may be computationally formulated utilizing multivariant parameters. For accurate categorization of the dataset, these are the distance techniques they used, which is Euclidean and Manhattan distance techniques. Now coming to deep learning. Deep learning is a part of a machine learning methods, and so deep learning is a subset of machine learning, as we know, which is essentially a neural network with 3 or more layers. Here we have several techniques, which are CNN feature-based extreme learning using CNN deep learning features, and histopathological images with CNN, multi-layer perceptron, constructive neural networks, Fisher informative network with deep learning. Among these techniques, Histopathological images with CNN gave the highest accuracy, which is of 98%. In this method, what the authors have done is they use the convolution neural network with a MIA's data set to discover the final training data set. They constructed an encoder after the extracting useful features from the histogram and watershed the model. So here, all the features are not used. So basically, this is the main issue from this paper. All the features were not used. That is the reason why it showed the highest accuracy, and it might have given it will give the less accuracy in the testing data. Coming to transfer learning, we have several transfer learning techniques. So to know first what transfer learning is, transfer learning focuses on storing knowledge gained while solving one problem and applying it to different but related problem. So basically, we have several methodologies were used in transfer learning, which is inception V3 and all, DCNN descriptor with global pooling and inception, CNN with VGG19, transfer learning with CNN, and quantum transfer learning. So in here, in the techniques which are in transfer learning, Inception V3 and ResNet 50 have shown the highest accuracy, in which the Inception V3 is a superior version of Inception V1, and it is improved version, and it is a deep learning model based on the convolution neural network, which can be used for image classification, which is a variant of ResNet, and which have 48 convolution layers with one maximum money average pool. So here is what the techniques explored in the transfer learning. Here, the issues in the current systems are early detection. Early detection is still a big issue in detection of the breast cancer, and the accuracy. So accuracy are still an issue, and to the existing models, whatever techniques we have explored till now, it still shows its accuracy is a major issue. So even the technique is showing the highest accuracy, like 99 or 98%. All the features are not used to train the data set to provide accurate results of the test data.
Now we come to the conclusion part. As breast cancer is a common disease nowadays, its death ratio is increasing day by day. So even though we identified several techniques to detect them, its early detection and accuracy is a question mark. And data sets whichever we are using have several limitations too. So for this, we suggested to trying the image data instead of variable data set, because the dataset contains the histopathological data of cancer tissues, so which can be processed using several techniques. So, and the various limitations provided by the machine learning techniques can be further improved by transfer and deep learning. So, as our future scope, we'll try to implement the system with transformers. So, they have gotten worldwide recognition, and their accuracy level is comparatively higher than convolutional neural networks. So that's all about the presentation. We are concluding by saying that we covered most of the pre-processing, feature extraction, feature selection, classification techniques like supervised, unsupervised, deep learning, transfer learning, and the data sets available for breast cancer in comparison of their accuracies. So in future, we'll try to improvise the system with transformers. So thank you for this opportunity.
Thank you for giving this opportunity.